there's two ways of thinking about it. One, yeah, it makes it more stable. That's good. You caught that. You know, this bottom water makes it more stable O2 compared to a less stable hydrogen peroxide. And number two, the bottom water is more reactive because it's closer to lithium, right? And so it should be that. All the other waters here, do you see all the other waters have something else associated with them? You can't use those. And so it turns out, this is very good, it turns out that water is both an oxidizer and a reducer. How about these other species here? Is silver both an oxidizer and a reducer? Does silver metal occur on both sides of the chart? And yeah, the answer is no. It's not. Nor does H+, nor does nitrate. And so this can go both ways. In acid-base chemistry, it's called amphoteric or amphiphilic. You know, water can act either as an acid or a base. Well, there's no fancy word for it in redox, unfortunately. Maybe there is, but I'm not familiar with it. But this can go both ways. It can either be an oxidizer or it can be a reducer. Sometimes, you know, the things aren't equal. Like water's, you know, pretty much equal. It doesn't care if it acts as an acid or a base, but sometimes certain species do care. There's a preference for one reaction over the other. But we're going to ignore that because the next step here is this. So we consult the chart and we want to determine the strongest OA and strongest RA. And we're going to find the strongest oxidizer and the strongest reducer. And that's going to give you the greatest pull on the electrons and the species that's going to lose them the easiest. And so this is the most likely reaction to occur. And so we just use the chart. You know, a lot of people say this is not in the book. Yes, this is not in the book. And then they say, since it's not in the book, you know, it's too much. It's too complicated. We don't have the book to read. But, you know, this method to me is a method that, you know, you probably can train an elementary school child to do it because they don't have to understand any chemistry. You know, it's just looking at the chart, right, and finding the species on the chart, knowing what side it's on. And so even though it might look complicated, it's not. Once you do a few of these, it's very easy. And so we go here. And so we just look, how many oxidizers do we have? We have 3, H+ alone, H+ and nitrate, and water. And so which one of those 3 is the strongest? We just start off at fluorine and work our way down, and the first one we hit is H+ and nitrate, nitric acid. Although sometimes this doesn't look like nitric acid. There's 1 nitrate and 4 H+. Shouldn't be 4 nitrates with 4 H+? Yeah, nitric acid is. You know, it's a 1-to-1 ratio. But in this reaction, you know, it doesn't react. Not all the nitrates react. So 3 of them would be spectators. We'd have leftover nitrate. And 4 of the H+ would be consumed. Then we go down. Way down here is H+ alone. And then way down here is water alone. And so, for sure, the strongest oxidizer will be H+ and nitrate. Okay, we find the strongest reducing agent. We have a choice, silver or water. So, start over here, chart. We'll look for silver and water. And then going up the chart here, I start at lithium. Here I have silver, but it's with bromide. Well, I don't have any bromide, so I can't use it. Here I have silver with chloride. I can't use that. Here I have silver alone. And so take a look. Silver with bromide, silver with chloride, is it more reactive or less reactive than silver alone? Is silver metal with chloride more reactive or less reactive than silver alone? More reactive. Why? Why would you suspect it's more reactive with chloride than with silver alone? Can you repeat that? Sorry. It's closer to what? It's closer to lithium, yes. Yeah, why do you think it's closer to lithium? That's the next question. You know, obviously the first thing, you know, like an elementary school child, you just say, oh, it's closer to lithium or closer to this, you know, that's enough. But obviously we want to know some chemistry. You don't have to know any chemistry to use this method, right? You can get the right answer without using any chemistry or having any knowledge of chemistry. But since we have knowledge of chemistry, why do you think silver solid with chloride is more reactive than silver solid alone?
Silver solids are stable.
Well, both of them are silver solid. You got silver solid and silver solid.
The silver solid alone is more stable than having the chloride and bromine.
The silver is not really bothered by the chloride. Chloride's not attacking silver. Silver is a metal. Metals are electron rich or electron poor in general. Electron rich. However, silver is doesn't like to lose its electrons so easily. Silver is called a coinage metal. So even though there are electrons there, it holds on to them more tightly. Now the chloride, does chloride want electrons? Chloride wants electrons? No. Chloride's already got an octet of electrons. It's not going to bother silver. That's not it. Think again. Pause this here.